In section 6.2, we're looking at factoring trinomials of the form x squared plus bx plus c. Our objectives are to factor trinomials of the form x squared plus bx plus c, and to factor out the greatest common factor, and then factor a trinomial of the form x squared plus bx plus c. Factor each trinomial completely. If a polynomial can't be factored, write prime. Here we're looking at the first polynomial, x squared plus 11x plus 30, also called the trinomial. And in order to factor this, we look at the last term, which is positive 30, and we list the factors of positive 30. It could be positive 1 times 30, 2 times 15, 3 times 10, 5 times 6, or any of these negative as well. Negative 1 times negative 30, negative 2 times negative 15, negative 3 times negative 10, and negative 5 times negative 6. When factoring a trinomial of the form of x squared plus bx plus c, you look at the c, the constant, find all the pairs of factors, and you want to find the pair of factors that will add up to the middle term. Our middle term is 11x. So we want the pair that will add up to a positive 11. And that pair of factors is 5 and 6. So we can write this in factored form as x plus 5 times x plus 6. So our answer, factored form, is x plus 5 times x plus 6 as two separate factors. You can always check your work here by using the FOIL process. The first, the outer, and the inner last. That will end up as your original polynomial. The first, when we multiply x times x, you do get x squared. The outer, x times 6, is plus 6x. The inner, 5 times x, is plus 5x. And the last is 5 times 6, which is 30. By combining those middle terms, we see we get x squared plus 11x plus 30. So we know that that was what we started off with, x squared plus 11x plus 30. So the answer in factored form is one factor of x plus 5 and the other factor of x plus 6. For b, we want to factor y squared plus 7y plus 10. So we begin with the constant at the end, the positive 10. You can write it as 1 times 10, 2 times 5, negative 2 times negative 5, or negative 1 times negative 10. You want to find the pair of factors that will add up to that middle term of plus 7, and that is a positive 2 and a positive 5. So our factors are y plus 2 and y plus 5. This is our answer for factoring the trinomial. And again, you can always check in the check step when you have a binomial times a binomial. You can use the FOIL process. The first is y times y, which is y squared. The outer is y times 5 plus 5y. The inner is plus 2y, and the last is plus 10. By combining those middle terms, we have y squared plus 7y plus 10. That was the problem that we started off with, so we know that we have found the correct factors. In example C, we have x squared plus 3x minus 4. Begin with the last term of negative 4. The pairs of factors that when you multiply them together give you negative 4 is negative 1 times positive 4, negative 2 times positive 2, negative 4 times positive 1. And now we want to find the pair of factors that if you add them will give you the middle term of a positive 3. And that pair of factors is negative 1 and a positive 4. So our factors are x minus 1 and x plus 4. Now you could write it this way, or you could write it as x plus 4 as the first factor, and then x minus 1. Either way, your answer is equivalent. And you can always check your work by using the FOIL process. So if our answer is x plus 4 times x minus 1, using the FOIL process, x times x is the first, x squared. The outer, x times negative 1 is a negative x. The inner, plus 4x, and the last minus 4. By combining the middle terms, we get x squared plus 3x minus 4. That was what we started off with, so we know our final answer is one factor of x plus 4 and the other factor of x minus 1. In example D, the trinomial is x squared minus 4x minus 21. We look at the negative 21, the last term, and find the pairs of factors. Negative 1 times 21, negative 3 times positive 7, negative 7 times positive 3, and negative 21 times 1. And we find the pair of factors that when you add them together will give you that middle term of negative 4. And that pair of factors is negative 7 and a positive 3. So in factored form, we have x minus 7 as one factor and x plus 3 as the other factor. We can check our answer by using the FOIL process. When we multiply the first, x times x is x squared, the outer is plus 3x, the inner is minus 7x, and the last is minus 21. By combining the middle terms, we see that x squared minus 4x minus 21 is what we started off with. For example E, we have x squared minus 13x plus 30. We begin with 30 and list the pairs of factors. 1 times 30, 2 times 15, 3 times 10, 5 times 6, negative 5 times negative 6, negative 3 times negative 10, negative 2 times negative 15, and negative 1 times negative 30. And we want to find the pair of factors that will add up to that middle term of negative 13. So our pair of factors is negative 3 and negative 10. In factored form, this is written as x minus 3 and x minus 10. We can check this step by using the FOIL process. X times x is x squared. The outer is minus 10x. The inner is minus 3x. And the last is plus 30. By combining the middle terms, we get x squared minus 13x plus 30. Example F, x squared minus x plus 32. We begin with the 32 and list the pairs of factors. 1 times 32, 2 times 16, 4 times 8, negative 4 times negative 8, negative 16 times negative 2, negative 1 times negative 32. We want to find the pair of factors that will give you that middle term of negative 1. But when you add those factors together, 1 plus 32 is 33, 2 plus 16 is 18, 4 plus 8 is 12. It doesn't look like any of these is going to give you that middle term of negative 1. So in this case, we can say that this trinomial is prime, meaning that it cannot be factored. Example G, m squared plus 17m plus 16. Let's list the pairs of factors of positive 16. 1 times 16, 2 times 8, 4 times 4, or negative 4 times negative 4, negative 2 times negative 8, or negative 1 times negative 16. Find the pair of factors that will give you a positive 17, and that was our first pair of factors. So our trinomial can be written in factored form as m plus 1 and m plus 16. By using the FOIL process, we can check our solution, check our factors, by multiplying the first. M times m is m squared, the outer is plus 16m, the inner is plus 1m, and the last is plus 1. By combining the middle terms, we get m squared plus 17m plus 16. That's what we started off with. So in factored form, that trinomial can be written as one factor m plus 1 and the other factor of m plus 16. In example H, we have 5x minus 14 plus x squared. Before we start factoring this, we need to write it in the form of x squared plus bx plus c. So we're going to rearrange the terms so we get x squared plus 5x minus 14. Now we look at that last term, negative 14, and list all the pairs of factors of negative 14, which are negative 1 times positive 14, negative 2 times positive 7, negative 7 times 2, and negative 14 times 1. The pair of factors that will give you that middle term of positive 5 is negative 2 and a positive 7. So in factored form, we can write this as x minus 2 and x plus 7. Again, as always, you can check your work by using the FOIL process. X times x, the first is x squared, the outer is plus 7x, the inner is minus 2x, and the last is minus 14. By combining the middle terms, we see we get x squared plus 5x minus 14, which is what we started off with. Example I, we have a special type of trinomial that has two variables, a squared plus 13ab plus 40b squared. We can still follow the same process, however we're going to have both a's and b's in each factor. So let's look at the last constant here, 40. The last coefficient is 40, and list all the factors of 40. That's 1 times 40, 2 times 20, 4 times 10, 5 times 8, negative 5 times negative 8, negative 4 times negative 10, negative 2 times negative 20, and negative 1 times negative 40. So look for the pair of factors that will add up to that middle term. The middle coefficient is plus 13, and 5 plus 8 equals 13, and 5 times 8 is equal to 40. So we can write our factors as a plus 5b and a plus 8b. In factored form, that trinomial can be written as one factor of a plus 5b, and the other factor is a plus 8b. We can still check our work by doing the first, outer, inner, and last. The first, a times a, is a squared. The outer, a times 8b, is plus 8ab. The inner, 5b times a, is plus 5ab. And the last, 5b times 8b, is 40b squared. By combining the middle terms, we get a squared plus 13ab plus 40b squared. For these examples, we want to factor each trinomial completely. Some of these trinomials contain a greatest common factor other than 1. Don't forget to factor out the GCF first. Example A, we have 2x squared minus 18x plus 28. Before I look at the last term and start listing the factors, I want to look at all of the coefficients, and I notice that they're all even numbers. So there is a greatest common factor of 2. So the greatest common factor of all these is 2. We're going to first factor out the 2. And when we factor out that 2, it's the same thing as dividing each of those by 2. And 2x squared divided by 2 is x squared. Negative 18x divided by 2 is negative 9x, and 28 divided by 2 is plus 14. So one factor is 2 out in front, and the other trinomial inside is x squared minus 9x plus 14. But this trinomial inside we're going to see if we can factor by looking at that last term, 14, listing all the pairs of factors of 14. It is 1 times 14, 2 times 7, negative 2 times negative 7, and negative 1 times negative 14. There is a pair of factors that will add up to give you that middle term of negative 9, and those factors are negative 2 and negative 9. So in factored form, 2 is the first factor. Don't forget about that GCF. The first factor, which is a linear factor, is going to be x minus 2, and then the x minus 7 is the other factor. So in factored form, the trinomial can be written as 2 times a factor x minus 2 times a factor x minus 7. You can use the FOIL process again to check, and then at the end you can multiply by 2. So if you use that, we multiply the first, x times x is x squared, the outer is minus 7x, the inner is minus 2x, and the last is plus 14. You can combine the middle terms to get x squared minus 9x plus 14, but then you need to distribute that 2 to get 2x squared minus 18x plus 28. And that's what we started off with, so that we know we have the trinomial in factored form. In example B, we have 3x squared plus 6x minus 9. Let's look at the GCF for each of those terms. They're all multiples of 3, so my greatest common factor for all the terms is 3. When we factor that 3 out, we'll be left with x squared plus 2x minus 3. So the trinomial inside the parentheses, we're going to try to factor that. I'm going to look at the factors of that last term, negative 3, which is 1 times negative 3, or negative 1 times positive 3. And that pair of factors that will add up to that middle term of positive 2 is negative 1 and a positive 3. So in factored form, this trinomial can be written as 3 as one factor, times x minus 1 as the second factor, and x plus 3 as the third factor. You can check this by using FOIL and then multiplying the result of that FOIL by 3. So the first, when you're doing the FOIL with the two factors, x minus 1 and x plus 3, x times x is x squared, the outer is plus 3x, the inner is minus 1x, and the last is minus 3. By combining the middle terms, you get x squared plus 2x minus 3, and then by distributing the 3, you get 3x squared plus 6x minus 9, and that's what we started off with. In example C, we have x squared plus 10x plus 24. There is no greatest common factor for all three of those terms, so we go to the step where we're looking at that last term of 24. Let's find all the pairs of factors of 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6, and so on and so on. And then once you find that pair of factors that does add up to that middle term, there's really no need to continue listing the factors. In this case, we're trying to find the pair of factors that will add up to positive 10. So in factored form, this trinomial can be written as x plus 4 and x plus 6. We can use FOIL to check our factored form. When we multiply x times x, our first is x squared, the outer is plus 6x, the inner is plus 4x, and the last is plus 24. By combining the middle terms, we get x squared plus 10x plus 24. To factor 2x squared plus 20x minus 22, we begin by factoring out the greatest common factor. I notice that all the numbers, the coefficients, and the constants are even numbers, so I know 2 is the greatest common factor. If you factor out a 2, that's the same thing as dividing each of those by 2, and we get 2 times the quantity x squared plus 10x minus 11. Now the trinomial inside the parentheses is something we can factor further. Looking at that last term of negative 11, we list all the pairs of factors of negative 11, and we want to find the one that will add up to positive 10. So negative 1 times positive 11, or negative 11 times positive 1. The pair of factors that will add up to the positive 10 is the negative 1 and the positive 11. So the factors are x minus 1 and x plus 11. So in factored form, the entire polynomial can be written as 2 times the factor x minus 1 times the factor x plus 11. And you can check this by using the FOIL process for the two factors x minus 1 and x plus 11, and then multiplying that result by 2. So when you do the first, x times x is x squared, the outer is plus 11x, the inner is minus 1x, and the last is negative 11. By combining the middle terms, you get x squared plus 10x minus 11, and then by distributing the 2, you get 2x squared plus 20x minus 22. In the second example, I see that the trinomial 5x squared plus 20x plus 15 has the greatest common factor of 5. So we want to factor out the 5 before we factor the trinomial. When you factor out the 5, you're dividing each of those terms by 5. So 5x squared, factor out the 5, is x squared. 20x divided by 5 is plus 4x. And 15 divided by 5 is plus 3. Now we look at the trinomial inside the parentheses. The last term is a positive 3, so we list the factors of positive 3, 1 times 3, or negative 1 times negative 3. The pair of factors of negative 3 that will add up to positive 4 are the positive 1 and the positive 3. So in factored form, this polynomial can be written as 5 times a quantity x plus 1 times a quantity x plus 3. Now we can check our work by multiplying. We have the 5 out in front, which will distribute after we do the FOIL process with the two linear factors. Outer first is x times x, or x squared. The outer is plus 3x, the inner is plus 1x, and the last is plus 3. By combining the middle terms, we get x squared plus 4x plus 3. And then distributing the 5, we get 5x squared plus 20x plus 15. So it works that the factored form is 5 times the quantity x plus 1 times the quantity x plus 3. In example F, we have negative x to the third plus 3x squared plus 10x. The greatest common factor of all three of those terms is x. But since the leading coefficient is negative, I'm going to factor out a negative x as our greatest common factor. When you factor out the negative x from that trinomial, it's like we're dividing each one of these by negative x. So we have negative x times a quantity of negative x cubed divided by a negative x is a positive x squared. 3x squared divided by negative x is a minus 3x. And 10x divided by negative 2 is negative x is a negative 10. Now we want to factor the trinomial, x squared minus 3x minus 10. So we want to find the factors of negative 10 that will add up to a positive 3. Negative 3. So we can write this as negative 1 times 10, negative 2 times 5, negative 5 times 2, or negative 10 times 1. And the pair of factors of negative 10 that will add to give you a negative 3 are negative 5 and a positive 2. So in factored form, this polynomial is negative x times the quantity x minus 5 times the quantity x plus 2. We can check our work by multiplying the factors x minus 5 and x plus 2 together and then distribute that negative x. The first x times x is x squared. X times the positive 2 is plus 2x. Inner minus 5x minus 10. Distributing that negative x, we get negative x to the third. By combining the middle terms, we get negative x times the quantity x squared minus 3x minus 10. And distributing that x, we get negative x to the third plus 3x squared plus 10x. To factor 4x to the fourth minus 36x to the third plus 56x squared, we want to factor out the GCF first. The GCF of all three of those terms is 4, because 4 goes into all of the coefficients, and all terms have x, so we factor out the x squared, the smallest exponent. When we factor out 4x squared from all of those terms, we're dividing out that 4x squared from each, and we get 4x to the fourth divided by 4x squared is x squared. The minus 36x to the third divided by 4x squared is minus 9x. And the 56x squared divided by 4x is plus 14. So we have the greatest common factor of 4x squared and the trinomial x squared minus 9x plus 14, which we can factor even further. So we look at the last term of 14 and find the pairs of factors that will add up to negative 9. And that pair of factors is negative 2 times negative 7 equals a positive 14, and negative 2 plus negative 7 will equal that negative 9. So we have the greatest common factor of 4x squared, and then that trinomial can be factored into x minus 2 and x minus 7. We can check our final answer by using the FOIL method with the two factors x minus 2 and x minus 7, and then multiply the result by 4x squared. When you do the FOIL method, you get x times x is x squared, the outer is minus 7x, the inner is minus 2x, and the last is plus 14. When we combine the middle terms, we get x squared minus 9x plus 14. And then when you distribute that 4x squared, you get 4x to the fourth minus 36x to the third plus 56x squared, which is what we started off with. For example H, we're factoring x to the third y plus 10x squared y squared plus 24xy cubed. Let's begin by finding the greatest common factor. Since all terms have x's, the greatest common factor is also going to include an x. All terms have a y, so the greatest common factor is xy. We factor that out first, xy, and that is like we were dividing out each one of those terms by an xy. So we get xy factor out in front times x squared plus 10xy plus 24y squared. So we want to factor this trinomial, and we're looking at the factors of 24 that will add up to 10. And the factors of 24 that will add up to 10 are 6 and 4. So it's a positive 6 and a positive 4. So our factored form is xy, that greatest common factor, and when we factor the trinomial, the first term is going to be an x plus 6y, and x plus 4y will be the other factor. So in factored form, we have xy times the factor x plus 6y times the factor x plus 4y. We can check our work by using the FOIL method and then multiplying the result by that greatest common factor. When we do the first, x times x is x squared, the outer x times 4y is plus 4xy, the inner is plus 6xy, and the last is plus 24y squared. Combine those middle terms to get x squared plus 10xy plus 24y squared, and then distribute the xy to get x to the third y plus 10x squared y squared plus 24xy to the third, which is what we started off with. In example I, we have 1/3 y squared minus 8/3 y minus 11. In this case, we're going to simplify or factor this by taking out the greatest common factor. In this case, we're looking at getting rid of those fractions that would make it easier to factor. So we are going to use 1/3 as our greatest common factor. We're going to factor out the 1/3, and when you factor out the 1/3, it's like you're dividing each one of those terms by 1/3. And remember that dividing by a fraction is the same thing as multiplying by the reciprocal. So 1/3 divided by 1/3 is 1. So the first term becomes y squared after the 1/3 greatest common factor is taken out. And then the negative 8/3 divided by 1/3 is going to be minus 8y. And the negative 11 divided by 1/3 is going to be the minus 33. Again, remember that dividing by a fraction is the same thing as multiplying by the reciprocal. Now we have this trinomial, the greatest common factor 1/3 out in front, and the trinomial y squared minus 8y minus 33. We're going to look at the factors of negative 33 that will add up to negative 8, and that is a negative 11 times a positive 3 is a negative 33, and when you add those together you get the negative 8. So our factors, we have the 1/3 greatest common factor, and then we have a factor of y minus 11 and a factor of y plus 3. That is our factored form for that polynomial. We can simplify this or check our work by using the FOIL with y minus 11 and y plus 3 factors. The first being y times y is y squared, plus 3y is the outer, minus 3y is the inner, and the minus 33 is the last. Combine those middle terms to get y squared minus 8y minus 33. And then we're going to distribute that 1/3 to get 1/3 y squared minus 8/3 y minus 11. And that's what we started off with.